project. At the time of submission of this work, RPM-based faster RCNN was not in the literature. So at that time, the state of the art was still RCNN, region-based convolutional neural network. So our entire work was based on that. So this is conceptually a very intuitive idea, which is shown here. So basically, the idea is instead of evaluating millions of candidates' windows in a sliding window fashion, the first step should be somehow limit the number of candidates so that you can apply more expensive CNN features to classify those regions. So in the last couple of years, we saw deep learning has really succeeded in the field of object detection in images. So one might ask the question, how the object detection in video is different from object detection in images. The thing is, unlike images, video frames has different levels of artifacts like motion blur, compression artifacts, poor quality, and so on and so on. But the thing is, it is temporally consistent. So this is one good point we can keep in mind. So probably one idea could be to use all the images, basically all the video frames, to analyze so that we can get better object proposals for video. But the problem is, for arbitrary long duration of video, this is prohibitive in terms of memory. We can't take all the image frames, all the video frames into the memory. So possibly one solution could be to process the video in a streaming fashion. What do you mean by streaming fashion is the processing of the current input should be dependent on the past output, but the current processing should not alter the past results. So this entire literature is called streaming processing. The idea is based on ECCV 2012 Stream GBH. So the thing is, we know that we have to do it in streaming processing. So the idea is to divide the entire video into some subsequences. Subsequences are a collection of video frames. Those subsequences should always consider one frame at least in common so that it can have this temporal consistency. So the thing is, we probably need to use the motion information so that we can have better object proposals. So what do you do for that? We extract the optical flow fields and use those optical flow fields to analyze and get object proposals for all the video frames. Now, another thing we need to keep in mind that most of the time in video object detection datasets, not all the frames are annotated. So we just use this optical flow to get better object proposals. Those can be substantially used for static and moving video objects. For training, we used YouTube video object dataset, which is from University of Edinburgh. And the methodology is we used only those frames which are available, for which the ground truth is available. And for the test time, we have another alternative framework which does the same way for video object proposals, and then based on the output from the previous subsequence, we cluster those object proposals and propagate the class levels. Thus, we do not need to classify all those object proposals and yet get good results in terms of object detection. So I probably am running out of time. So, okay, so these are the results. Please come to my poster to talk about it more.